Welcome to the second episode of making a MegaMan X game in Unity. Last time we worked on the very basic movement for the player, as well as setting up the input for the project. Today we're gonna continue working on that, and instead of basic stuff like the movement, jumps, stuff like that, we're gonna work on more MegaMan X based stuff, like wall jumps, slides, things like that. But before that happens, let's fix a few bugs that I realized from last time. First of all, even though the input has been set up, I forgot to assign any buttons for the jump and dash. So let's start with that. Don't remember where it is, like I kinda forgot. Go over to the project setting. Yeah. Input system packet and never mind. That's not correct. Over to presets and player input. Right. I really hope I didn't break anything. Anyway, so as you can see, the movement has bindings for the keyboard and the controller, but the jump and dash don't. So go over to this plus thing right here, add binding, select path, the gamepad, and you can select specific buttons like A, B, or for specific controllers. But I prefer just going to the generic gamepad buttons and selecting something like south for the jump and east for the dash. So no matter what controller you're using, it's gonna have the relative position. And I forgot to save the asset. So right, do that first. And no matter what controller you use, it's actually going to remember the relative position. So by default, the down button in the letters should be the jump and the right button should be the dash. So that's the first thing. Then after that, there are two small problems that have to do with the ledges, not ledges. Well, these areas, I forget what they're called. So yeah, first of all, if you try to jump right after landing on a ledge, sometimes it's gonna hit your input, and it's just not gonna work. And another issue is this thing right here, where if you move against the wall and you are going uphill, you're just gonna have this problem. First of all, to fix the small problem that happens when you try to jump, like the lesser of the two, let's go over to apply physics, and actually it's not right here, never mind. No, it should be. Never mind, so I'm gonna add a comment, and I'm gonna add comments to the entire project on this time, because I forgot the last one. But for now, when touching the ground, when you land. So what happens here is that when the player lands, their vertical velocity gets lost. It gets removed, so that if you land on a downhill area, you won't slide down. But the problem is that sometimes that actually eats up your jump input also. So if vector3 dot gravity back and dot velocity is greater than 0. So that way you check the direction of the gravity of the velocity versus the gravity vector. And if the player is going down, the dot product is gonna be positive. So in that case, it's gonna cut off your jump. It's gonna cut off the velocity. If it is a jump, it's not gonna cut off that one. So yeah, now this should be a lot easier. Yeah, it doesn't seem to be eating any inputs, so that's perfectly fine. Now, as for the next thing, this part is gonna be a bit more difficult. And this is also gonna be a nice segue into the wall slides. So first of all, let's get to the very bottom of the script. And public bool is called float add distance. Distance is equal to 0.1f. So similar to the isGrounded method, the check, what this is going to do is check if there is a hole right in front of the player. So this is also why you needed a face on the player and to set the rotations already, because this face, the forward of the player, is where they are looking. So right now, even in 2D without a mess, you're gonna have a reference of where they're looking, or a good idea at least. So start by creating a solid layer again. Solid layer is equal to 1, 8. And this just tells Unity what layer to check the objects in. Actually, you know what? Let's make this a constant real quick. Public constant int solid layer is equal to this. And so now we don't need to define a solid layer every time. It's gonna be a constant number, and that means that it's a variable button you can't change. So we can just use it like that. So to check if there is a hole right in front of the player, we're going to use check capsule as the method. And for that, let me bring Paint again real quick. Our favorite tool in this. And so, let's say the player has a collider like that. The collider is simply two capsules, and normally there isn't an area like that, but I'm not great at drawing the circles. So this would be the player. Now to check a capsule, we need 2 points. Point A and point B. And by using those and a radius like this, which is how large the circle is, we can do a check capsule. Now, this could be the player, but this could also be some random point relative to the player or in the absolute location of the world. So, this could be anything, just one random position in the shape of a capsule that we check for a specific collider, or all colliders in general. So this is how check capsule is gonna work. So called physics.check capsule transform position plus transform up times height times 0.5f minus radius times 0.9f plus transform forward times add distance. So this would be point A, this entire thing right here. What it's gonna do is get the player's position, add the point slightly up by the player's height times 0.5 minus the radius, and that 0.9 is so we don't check for walls, ceilings, or things right next to the player. So what this would do would be transform position plus height minus radius. 1, 2, 3. And then for the forward, it's just gonna move the thing forward where the player is looking. So 4. This will be how the point A works. We're gonna do the same for point B, except instead of saying plus transform up, we're gonna say minus. Then radius and solid layer. So now that way we can tell if the player is touching a hole, if they are right against the hole. Right, this also actually needs to be returned. So there, now they should be ready. And if we go to our move regular function and add plus is hold 0.1f inside this check right here, which is what changes the vector that the player moves along. So in an uphill, instead of the player moving like this, it would move like that, if you remember from the previous video. So we're only gonna make this change if there is not a wall right in front of the player. Because what happens if there is a wall is this vector gets split into this and that vector, and this vector gets added to their velocity. So the player would keep bouncing up while this vector doesn't work. They would still have a vertical velocity, a vertical displacement at least. So now, that way, if this worked, this should be all that we need to do. Nope, it did not work. Oh yeah, right. If there is not a role, how many times am I gonna forget to add a not in a function like this? I don't know. So if there is not a role in front of the player, they're gonna bounce. They are gonna move up. If there is, they're just gonna ignore that script entirely. And yeah, no, it works. You can move around and it's perfectly fine. Otherwise it works like normal. Okay, so now that we've got these small glitches done, and we've set up the isRolled script, it's about time to do the roll slide. Yeah, don't worry about the other Visual Studio project. I've already done a draft of this project, and I'll just have it as a it. It's pretty useful to have. I mean, if you're gonna compare, what we're gonna try to do today would be this thing, which is not exactly the same one that I showed last time, but we'll be adding rotor, wall sliding, dust jumping, and dashing, which works kinda like a slide. But yeah, this is our goal for today. I just have the project open and we'll slowly work towards it. So, first of all, what we need to do would be to check if there is a roll while the player is dropping down from gravity. And if there is one, then we're gonna limit their downwards velocity. So, apply physics, and we're gonna go right here over where gravity gets applied. So, after the normal addition of gravity, we're gonna check if is rolled 0.1f, and if they are, then we're gonna make vector 3 gravity grav is equal to vector 3 dot project body velocity gravity vector. If you remember what project and project on plane do, if you don't, let's say you've got this vector and you wanna get how it would be on that vector. Or let's say you wanna project this vector on that vector. The vector that you get at 90 degrees angle from this would be the projection. You can see the previous episode. Like, I guess I'm not gonna go over those every single time now. So the pace is kinda gonna get picked up. So if you need reminders, feel free to check out the previous episode. That's what project does, and project on plane would give you the leftover, like this vector right here. Which you could do another project on in this situation, but it's gonna return a 2D vector, or it's gonna return a plane. So this would be the normal, the vector, this would be the plane that it returns. So yeah, we're gonna do that project, and if vector 3 dot between the velocity graph is greater than 20. Actually, what value did I use? Hold on. Yeah, right, if it's greater than 4, then gravity. Actually, no, wait, it's the gravity vector and the local gravity thing here, the gravity velocity. Grav is equal to gravity vector times 4. Actually, let's make that a variable real quick. Plot wallslide speed is equal to 4, and if that means that, and there we go. And body velocity is equal to vector 3 project on plane, body velocity gravity vec plus grav. Wrong project. So what this would do would be that if we're facing a roll, we're gonna slide down slowly. And yeah, that works already. Okay, that's nice, that's a W. So let's make this roll much smaller real quick. Bring it down, and let's bring it down and make it a bit thinner. for convenience. So now, if you go up against the wall, you're just gonna slide down. If you're not, you're gonna fall like normal. That's nice, but we actually need to do that only when the player's input is actually telling us to do so. Sorry. Yeah, we only need to do that when the player is telling us to do so. If there is left or right pressed, then we do that. Otherwise, we don't have a reason to. Now let's add plus input control dot input dot x is not equal to 0. So input dot x should be either -1, 0, or 1. So when it's 0, the player doesn't move. When it isn't, the player moves. So when they are pressing the button either left or right, which we can't tell which direction they're looking yet, and we don't really need to, we're just going to use that velocity. There's no reason to check if they are pressing left or right here, since in both cases that works. So yeah, you fall like normal. If you press left, it works. And so this is ready. I'm actually gonna change this to a different. I'm gonna define a method that is called wall sliding. It's gonna make it a bit easier to tell, since this isn't going to be the only situation where we will need to check for a wall slide. So public bool is wall sliding, and we're not gonna add parentheses here because we're not gonna do the same thing as this thing right here. We don't need the parameters, so instead of that, it's gonna be slightly different in syntax. So that here I get and return this. And return this thing right here. So now go back to apply physics. Alright, it's already right here. And this should work like normal. It's not gonna make a sense yet, but it's gonna be nice to have in a bit when we start working on the wall jump. And as you can see, this doesn't really make a difference, but we're gonna need it in a bit. So now let's actually make the wall jump. So for a wall jump, we're gonna use a different concept. We're gonna use what is called the coroutine in Unity. So public enumerator core underscore wall jump. And so what the coroutine does is it lets you run a method over a set period of time or a variable amount of time. But you can run a script over a lot of frames. So let's say float time is equal to 5f, float speed is equal to 5f, then yield return new wait 4 seconds 1f, speed is equal to 4f. What this is going to do is set a variable speed to 5, wait for a second, and then change it to 4. And after that, yield return null or yield return new wait for end of frame. Both of them do the same thing. Wait is equal to 1. So this is gonna wait for a frame, or this one will do a frame. Both of them, there's gonna be a 2-frame delay, and the speed is gonna change to 1. Now, if you wanna change the speed during the timer, during a wait, like let's say of 5 seconds, float time is equal to 5f, while time is greater than 0.0 than 0f, time minus equals time delta time, and yield return null. And so now after that, speed plus equals time delta time. What this is gonna do is this is gonna be a 5-second delay, and over the 5 seconds the speed is slowly gonna go from 1 to 6. Though keep in mind that the delta time is not precise and the times here are not either. So it might be a bit more than that. So make sure if you need a precise value to set the speed to 6f at the very end. There's also a few more. There's also a few more things you can use right here, but they aren't really important right now. What's important is that you understand the basics of how a coroutine works, and that it's simply meant to be a function with a timer, or a lot of timers. Now, what we're gonna do with it is the whole jump is gonna be split into 3 phases, or you can keep it in your mind like that. We're not really gonna define the phases, but let's say the player is here sliding down a wall, then they jump from the wall, and then they've got the free movement to either go backward to the wall or to jump away from the wall. This will be phase 1, 2, and 3. So, during phase 2 specifically, you're gonna need to have a small delay where the player can't move at all, and you're gonna take away the input from them entirely. Then you're gonna delay for a bit of time, a fraction of a second, then give them the input back again with a jump velocity that's given at the very beginning. So we're gonna take a small trip around, go to the very top of the script, and make a new header. Call it checks and add public bool can move is equal to true, and public bool use gravity is equal to true. So if can move is now set to false, the player won't be able to move, and we're gonna use that for phase 2. And if use gravity is set to false, the gravity won't apply, which we aren't gonna need right now. But I like defining both of them at the same time, and we'll need it for the dashes, for air dashes, then maybe on ladders. So nice to have it in right now. First of all, go to handle input, and at the very top, if not can move, then return. So what this does is, if the player isn't able to move, then the script stops right here, and there are no checks for input or anything. Do the same to move regular, and if not can move, then return. Now you can put stuff above this check right here, and anything that happens before is gonna happen regardless of the can move check. But we don't need to do anything like that right now. One thing that does happen is the player input. The input controller gets updated regardless of the player's ability to move, but that happens outside of the method, and even if we placed it inside handle input, if it was right here, it would still work like normal. Apply physics also works like normal, it doesn't even depend on the player's move. What we need to do here is add a check for use gravity. And so now, let's actually check that real quick. Let's say yield return null, because you need to have a yield return in here, otherwise you're gonna get an error. And let's check how those two work real quick actually. Then we're gonna get onto the whole jump. So as you can see, they appear right here. Let's remove maximize on play so we can actually change them from the inspector. And the player can move and jump around like normal. If we remove can move, we don't have the ability to move around. Like jump, move, event, change the rotation, nothing. Then we remove gravity, and if we move the player, they're not gonna fall, but they can move around like normal. The slopes are supposed to work like that, since they aren't using the gravity, and without gravity the player may just do that. But you just apply gravity again and it's back to normal. And this works. Yeah, I don't think the whole slide either works, which is good, it's supposed to be like that. So the whole jump will be a fairly simple coroutine. What we're gonna do is set can move to false, yield return new, wait for second 0.15f, and then can move is equal to true. And right before the delay, we're gonna do body velocity is equal to minus transform forward times move speed minus gravity vec times jump force. And so what this does is it takes away the input from the player. It makes the player move against their forward direction plus up, and then it waits for a bit, and then it lets them move again. Now I'm not sure about the exact values on if this is correct, if those speeds are correct, or the jump force is correct. One thing that I did change on the previous project, and I think is more accurate, would be to change that to 25, the jump force, instead of 30. So now let's also do that in the script, just in case. Change that to 25, and let's, yeah, this should be good enough. Right, I forgot. We also need to actually tell the game to wall jump. So this is why we made the is wall sliding as a separate method, as a separate function instead of having just one check on the physics. Let's go to handle input. Then if the player is touching the ground, you're going to change the velocity to a regular jump. Else if is wall sliding, then start coroutine core underscore wall jump. And this is how you start a coroutine, by the way. You can't simply use that because it's not gonna run. You need to do start coroutine. And now this should work. And yeah, this works. This is a pretty nice normal wall jump. You can jump back to the wall or you can jump away from it. I think the values seem pretty decent, but I'm not sure if this is exactly the correct amount. So feel free to check it yourself and make sure, because I don't really know if that's the precise values that you want to use. So yeah, with that done, now let's actually work on the DAS. And the DAS is actually going to be another coroutine, but that one is going to be a lot more complicated. Public enumerator core underscore DAS. Actually, let's add the yield return here right first of all, because we're gonna make a small addition to the player. So the DAS, I'm not sure exactly in which games it happens, but in a lot of games, when you DAS, the collision for the player actually goes down a bit. And we might exaggerate that thing a bit, but we're gonna try to duplicate that. So collider normal, just get all the capsules and do this. If you're using an older version of Unity, it might not have create empty parent, so just create empty and parent everything else right here. Make sure that the capsule is set to triple zeros, and triple ones. To make sure that the relative positions stay the same, you could parent those to the original capsule. Also make sure that the original capsule actually has the collider, because that's the important thing right here. And the message we're gonna remove later when we make the models. But the collider needs to be under collider normal. Then duplicate this, change this to call DAS, scale it to 0.5 and change the position to minus 0.5. So now if you change this to wireframe, you're gonna see that the DAS collider is half the normal collider. You've got this and you've got that, and here's both the colliders. The player would look a bit squeezed, but that's fine, it doesn't really matter. I mean, later on we're gonna have proper models, so this isn't even going to be an issue. We're going to have visuals depending on the models, but for now it will give us a visual indication of what's happening right here. That's pretty silly, but it's normal. So disable this, and let's actually use this, grab them from the script. public game object called normal and public game object called dust. Go to start. Go to start and call normal.setActive true and call does setActive false. And so now, just in case, we're gonna start by setting the colliders to on and off properly. And then we're gonna go to the task routine and start working on this. So add the same two scripts to lines at the top and bottom, make a bit of space in between, and at the top part switch the trend false, so that the task collider is the one that's active. And after that, we're gonna set time. Float time is equal to 0.3f. Hold on, let me check real quick. Yeah, 0.3. And while time is greater than 0f, time minus equals time fixed delta time, and yield return new wait for fixed update. Since this is gonna be physics based, we're gonna wait for a fixed update. It's kinda like the difference between update and fixed update. If you remember from the video or you know how this works, that's nice, but I'll show you real quick. I'll do a pretty quick tutorial. So let's say this is our timeline, and this would be our fixed update. Like each one of these parts would be fixed update, fixed update, fixed update, fixed update, and all of them are approximately about the same size. I mean, they aren't exactly, but they're pretty much the same size. Like Unity tries to get them as close as possible. That's how fixed update works. Now, update on the other hand could be anything. It could be wild. It could be like this, like that, like this, then large caps, and anything really goes. It doesn't really matter. Each one of these blocks could be an update. So, since the physics happen in the fixed update, we're going to be using the fixed update. And it's likely going to be better for us overall. So while that happens, we're also going to use dot velocity is equal to transform forward times dash speed. Let's actually define that. Times dash speed, and go to the top, and let's say dash speed is gonna be 20. At the end, body velocity is equal to vector 3.0, and that's it. So, alright, we also need to make the input actually do a dash, like when it's needed. So input, otherwise if input control dot key dash is equal to key state press, then start coroutine dash. Sorry, door dash. Oh, and I just remembered another thing. Hold on, let's actually check that the dash actually works, and then we're gonna do something else, fix a small issue real quick that I forgot about. And let's see. It does not work. Oh, there's an error. Hold on. Right, don't forget to actually assign the colliders. Drag and drop the collider normal, collider dash right here, and this should work. And it almost works. I mean, it depends on the player input, but it works, kinda. Okay, let's fix something else real quick. So, normally in MegaMan games, when you jump and let go of the button early, you're supposed to make a smaller jump. But I forgot to actually add that last time, so let's go right here. Else if input control dot key jump is equal to key state release. Body velocity is equal body velocity vector 3 project on plane body velocity gravity vector plus body velocity vector 3 project body velocity gravity vec times 0.5f, and this should work. Pretty sure this isn't gonna cause any problem. Actually, no, never mind. Yeah, never say you're pretty sure there's not gonna be any problems, because we actually need to make sure this only happens when the player is moving up. So let's go to input, and if vector 3 dot body velocity gravity vec is smaller than 0, so if the player is moving up, only then change the velocity. And so now that should work. Let's try to do a full jump and then a small jump. And let's see. Full jump and a small jump. Let's change the value to 25. Let's see if that's gonna be too much, or because this seems a bit too, I don't know, maybe that works. Never mind. Yeah, no, this is great. This works. Okay, so back to the dash. First of all, move is equal to false, and fuse gravity is equal to false. At the very top, which is why it looked weird before. Attempt to try the variant again, and let's try it out again. So now, there we go. That works a lot better. But there's still issues. I mean, the coroutine is gonna get a lot more complex, so don't worry, there's a lot of things to fix. But for now, first of all, let's make it so that if the player hits a hole, that they're just gonna exit the dash. If is hold 0.1f, then break, and that's simply going to stop the loop. So now if we hit the hole, it shouldn't really matter. It's gonna stop the dash immediately. Yeah, like this. Oh yeah, I guess you saw what we're gonna do next. So this works against the walls, you can go up the slopes, but down is a bit of a problem. Now, thankfully, we have already settled this in the previous video. So we're simply gonna copy paste the code. It's the easiest way to do that. Just go to move regular, copy this part of the code, including move back, and paste it right here. But this is only going to move us right, or to the relative right vector. So what we're gonna need to do is check the direction of the player that the player is facing. So if vector 3 dot transform forward move vec is smaller than 0, move vec times equals -1. And so now this should work. What this does is take a right vector and make it a left vector. So this works, that works, going up works, going down works. It's great. And there we go. Now we also want to stop the DAS, the DAS, if the player doesn't have the input pressed. However, this is going to be a bit, well, not very weird, but remember this. Remember the update versus fixed update. The way we're making input and the way that Unity by default handles input, it's on the fixed update. So if let's say you wanna release the button right here, release, and Unity actually checks on this frame right here, it's not gonna realize that you have released the dash button, so the input isn't going to work. So instead of checking for a key state release, we're gonna check for a key state .none. So if input control dot dash is equal to key state .none, actually we could also check for a release, but the none is gonna be way more guaranteed. Or a release, then break. And there. Now when we release the button, the dash is gonna stop. Yeah, you can do small dashes, you can do larger dashes. And so that works. Now, this doesn't work since there's another thing we need to deal with. So, if let's say an enemy was attacking you, the collider being downwards would completely work, that wouldn't be a problem. However, methods like isRolled right here don't really work because we're using Unity physics through code, not through the Unity engine, specifically how it handles the scenes itself. We're checking through code, so we don't know which collider the player is using. So we are just going to add a check. If all does.active self, then these cells do that. So instead of doing a check capsule, we're gonna do a check sphere, which is the same idea pretty much. Just remove this part, remove these two check sphere. And now, if the player's collider is large, it's gonna have the large check. If it's small, it's gonna have the small check. So let's see if this works. This does not. Alright, then start to 0.5. So let's change all of those. Yeah, sure. I mean, this is gonna make the isRolled check a bit smaller than the entire roll, but that's fine, since we don't need to be able to check the precision on this roll. Let's check. And now this works. It doesn't work perfectly, as you can see, but it works. I mean, we've got things like that, which is an issue. So we're gonna figure them out in a bit. But for now it works. Yeah, so we need to make sure that the player doesn't get up if they're hitting a ceiling. But this is only going to be a problem if the player is in a normal ground dash. An air dash shouldn't be an issue, so let's actually make that first. Let's see. Over here over time, also bool is air dash is equal to not counted on 0.3f. And also, these two things will only going to happen. No, wait. Yeah, no, not yet, don't worry about it. But the ground dash is. There is another condition where it stops. So, if you're on a ledge and you dash out of that ledge, you should stop dashing. So you should lose the dash and not keep going midair. So if not air dash and not is grounded 0.3f, then can also break. So that's another condition that's nice to have. But this isn't the important thing. The important thing for the air dust is that you can't jump out of it. And you also, you can't jump out of it. So let's actually make a dust jump. I really need to add comments to this, so actually I'll do that after the video, and the GitHub project will have comments, but this one doesn't yet. So don't worry about it right now. The GitHub project will have comments. The first one didn't, but I'll try to add them from now on. So go over here. If input control.feedSum is equal to hold, again because of a fixed update, and not is airdashing, then can move is equal to true, use gravity is equal to true, body velocity is equal to transfer map times jump force, and brake. Yeah, actually I think this was supposed to be after the thing that we're doing right now. But let's see. Yeah, and let's also need to make sure that, well, we need to make the player enter a dust jump phase, so public ball dust jumping, or is dust jump is equal to false. So go back to the dust and use dust jump is equal to true. So now if there is not a dust jump, then change the velocity to 0, and this would let us jump out of a slide. Now the dust jump is set, but it's not defined yet, so we're gonna do that in a bit. And yeah, you can now jump out of a slide, so that's nice. Okay, before we actually get too far into the dust jump, which for some reason I went to that, my mind went to that, and this is not the right order. Let's actually make sure that the player can check if they have a ceiling ahead of them, on top of them, and if they do have a ceiling, they can't exit the dust if they are on the ground. If they don't have any floor under them, it's fine, but in that case, yeah. Public pool is ceiling get return. No, wait, actually let's call it constant. No, has ceiling works a bit better. For that, we're gonna do another check sphere, and we're just gonna copy that. We don't need the capsule part, just this. And instead of down, make sure it goes up. And this should work. So if there is a ceiling, then we need to to give the player the ability to move around and to lower not lower the time to 0. So we're actually gonna go after that, and if time is smaller or equal to 0 and is counted and not constant, not has ceiling, then time is equal to 0.1f, so the player doesn't exit the input, and we're actually gonna let the player change the rotation in that case. Actually, let's make that 0.1f for consistency. If input control.input.text is not equal to 0, then transform rotation is equal to quaternion. Look, rotation, right back, times input control dot input x, and with minus gravity. And so now that's gonna let the player rotate if there is no input around, if there is a ceiling on top of them. But we also need to make a few more conditions where they don't exit the dash phase. So this and that can only happen when the player can actually jump, can actually stand. So if can stand as sailing, yeah, can you tell that I'm looking at the other project? Then if it has a ceiling, then if there is a roll, get up, or if the button is pressed, then get up. Actually, if not is air dash, and because if it is an air dash, actually you could potentially enter an air dash and then get onto the ground. And also this needs to be a not has ceiling. Yeah, if not, then air dash or is grounded 0.3 f, and this. If it's just grounded, since if it's not an air dash and the player is not grounded, that wouldn't happen anyway. So if the player is grounded and they don't have a ceiling, then they can jump up. So yeah, since that has a ceiling, so that if they have something above them, they don't exit the dash. Right. That's another error. Hold on. First of all, let's make this a bit longer so that the player can actually test it out properly. Or I guess you can test it out properly. And then go back over here. We don't need any forward displacement to check in front of the player, it's just above them. So now this should work. Hopefully. It does not. Well, it did not before, but now it does. That's a bit concerning, but releasing the button doesn't. Oh, okay. Happened now. 0.9. Yeah, that may be the reason why. Oh, the jump. Okay. The jump also needs to happen when you don't have a ceiling on top of you. And node has ceiling. And that remains an issue. I mean, it doesn't do that now, and you can move left and right. Normally on the desk you can't, but wait, let's make that 0.3 because everything else inside the dash method has been using 0.3. So maybe that's the reason. I don't know, maybe. Yeah, well, anyway, I'm gonna test it out later after the video, and if I figure out the issue, or if that didn't even fix the issue in the first place, I'm gonna change that and have the fix in the GitHub, or anyone else can figure it out and let me know, feel free to, it would be nice. I should leave links to Discord, Twitter, and you can also raise an issue on GitHub. Actually, that might be the best way, just raise the issue on GitHub. But if not, you can also let me know on Twitter or on Discord. There are any issues, but if the issue isn't fixed, I'm gonna try on my own a bit first before I upload it. So yeah, let me know. But I think for now this is good enough. So let's get to the next thing. The next thing would be to do the dust jump, and that's gonna be fun. We already made it so that it triggers when you jump while dashing, but we're not fully there yet. First of all, we need to actually cancel out the dust jump, and that happens when the player touches the ground. So, first of all, let's go over there to the gravity direction, or that happens when you land. Also, dust jump. Yeah, so this is if the velocity is negative, so as the velocity changes, the dust jump is equal to false. And so what the dust jump does is it replaces the player's normal movement speed with their dust speed. So they can dust jump away from an enemy or from a wall. And to change that, we're simply gonna go over here and change the move speed to speed. Let's actually just define it right here. Float speed is equal to move speed. If it's dust jump, then speed is equal to dust speed. And we could simply do we could do is dust jump, dust speed, otherwise move speed. But it's nice to actually have a specific variable for the speed right here, since you can also change that in the future with any other status effects or for other reasons that you may have. Maybe the player is nice or something. But yeah, there are a lot of reasons to change that, to have a specific speed value. But in any case, now that should work from a dash. Let's also make it so that if you hold jump and you're holding down the dash button, that also does it. So if input controller dot dash is equal to state hold, or input controller dot dash is equal to state press, just in case, is dash jump is equal to true. So change that to is dash jump, dash speed, that's this. Yeah, we are actually doing that here, so that works. Also, you need to remove the dust jump when the player is also wall sliding, since the player isn't supposed to maintain a dust jump after a wall slide. So let's also do that. And I'm not sure if I'm forgetting anything, but I think this is it. I think that's it for now. Actually, only if can move, because if the player can't move, then there could be wall jumping. So yeah. Now this should all work overall. Right. Well, I mean, another thing, you shouldn't be able to do dash if you're touching a wall or you're up against the wall. No, that's not supposed to happen at all. But besides that, the dust jump actually works. I think you should also enter the dust jump if you jump normally and you are holding down the dash button. fairly sure that's the case. I could be wrong, but I believe that's how this works. So just get right here, copy the code, and find input, dump. Actually, I could simply add it above everything else, but there may be situations where you don't want to dust jump. So let's just have it here real quick. Like maybe you wanna get off a hover, so that wouldn't need the dust jump. So yeah, that works. Works pretty well as it is right now. Right? Also, let's fix that whole issue that I just made. Oh, actually, that's different. And not has ceiling. Has ceiling. Then break. Then if not has ceiling, if it's grounded and not has ceiling and this, there. And also make sure that the player doesn't dash against the wall. And not is hold, is hold, hold 0.1f, then 13 dash. I think this is it. Hold on. I'm gonna remove these LEDs real quick to make it a bit more convenient to play around and figure out different how this works. So yeah, from a dust you can go to a dust jump, normally that's thing. You can also do a dust jump from the spot. Like here from a wall jump you can dust jump. You can dash and you can't dust jump from there, you can dust jump from here. Your collider gets smaller and you can go under walls. It doesn't seem to be changing, you can leave the collision, the dash early. Oh yeah, one last thing I think. So, in at least a few games, when you let go of the dash button or when the dash ends, if you are on the ground, then the player does a bit of an ending to the dash animation. So, at the very end, they've got that end of the animation that they do. So let's do that. Go over to the dash. Under the function where it is not dash jump, right here. And also, if not is there dash, and is grounded 0.3f, so if the player falls off the thing, they don't do that, then that time is equal to 0.2f. We are using the same timer variable as before, but we're outside its first loop, so we don't worry about that. We can use the same timer after its loop has ended. We don't need to define a new one, and if you did float this, it would give you an error anyway. So their float time is equal to 0, while time is greater than 0.2f, then time, well, body velocity is equal to vector 3, move towards body velocity vector 3 dot 0 with time fixed delta time. 150th, that's a large value, it's not really that important. It's time fixed delta time, field return null. And so this is slowly gonna remove the player's velocity from a dash to a stop, but it's not really fully gonna reach a stop. And it's gonna be very fast, so you're not really gonna notice it during gameplay. If input dot, actually input control dot jump is equal to press. I'm actually gonna change all of that from fixed delta time to delta time. And oh, this was null, so this would have been on normal update anyway. So yeah, on delta time, if it's press, then break. And so if the player presses the jump button, they're gonna break out of that. And yeah. Actually, the colliders need to change way before this, but the animation should play for a bit longer. The movement should play for a bit longer. I'm not sure if it actually runs if the value on body velocity is too high or not. Yeah, no, okay, so it does work, the velocity is just... This is just gonna take a bit of time to find the right value. So if this isn't it, I'm gonna take a small break and see you later. Yeah, break time. So let's actually make sure that this is correct. Continue. Oh, never mind, I'm dumb. Instead of 0.2, make this 0.0. And 150 should work, the original value. Yeah, I don't know if this actually shows through video, but there's a small post movement animation. Post after the dash, there is a small delay that slowly goes down. And as you can see, the minimum distance you can move is about like that. It's a bit larger than before. So yeah, this works, and I believe we're done with the dash. So we're not gonna have enough time to add the ladder movement, but we're going to have plenty of time to add a bit of water movement. The water is going to be extremely easy to add, so let's do that real quick. Over here, duplicate, name it water, change the layer to water from solid, set the collider to trigger, make it larger, specifically do this, then change the scale here 1.5 so that it covers everything else. Over to temp and duplicate the material, name it matte underscore water. Feel free to capitalize the W, change the rendering mode to transparent, color to a nice blue with alpha, assign it to the water, and visually this should be it. Now go over to Visual Studio, find Apply Physics. Actually no, first of all go under, copy is walled, and solid is in water. Yep. Remove this parts and change this to water layer. Change that water layer and go to the constants. Public constant int water layer is equal to 1 and place 4. actually move those to the very top of the script. Usually constants are added to the very top of the script. And when we make a game manager, we're gonna move that there. But for now, this works. So now to apply physics, since this to if is in water, else, and multiply with 0.5. Yeah. So now go to your game and wait for it to load and test it out. Your normal jump is like this, your water jump is like that. And we've got water. Oh wait, that's actually that's an issue. You enter a dust jump state no matter what when you hold jump. So if the key does pressure hold, else his dust jump is equal to false. Okay, we actually need to set an else key. Okay, that works. And so now we've got the water done, the dust jump, and the wall slide done. Wall jump also. Oh, that's an issue. You actually can't dash against the wall if against the gap if there is a hole right in front of you. Okay, we're gonna make a small change to the project. We're gonna add another variable right here. Is ducking. Let's actually say ducking because we're going to. I guess we could always implement a duck. So why not? It's ducking. And now let's find all the references of isWorld. There's 5 references as you can see right here, with Shift and F12, or if you've got a different version of Visual Studio, it might be different. Right here, and this is literally the only one we need to check. Actually, no, we need to change all of them. This will be set to true, and the rest will be set to the original condition. This and that, and this, and nope, that's the condition. And those. And now this should work. Final glitch near the end of the video. There we go. I mean, last time, the last few minutes, were also spent debugging the video, debugging the different stuff. Yeah, this works. I mean, here we go. The water works, everything else works, and that's nice. And now we've got a much more MegaMan X-like game. So, next video. Next video, there are 2 possible paths this could take. We could work on more obscure MegaMan X stuff, or well, not obscure, but less fundamental components, like climbing up ladders, adding hovers, multiple jumps, stuff like that. I'm not sure what else yet, but we could do that. We could also do the models and the characters for them. Models and animations, which are going to be a whole episode by themselves. I might even do some speed modeling on a lot of them, where there's music, it shows fast what's happening, and like this could be the other approach. Add animations and models. So, which one would you like to see? Would you rather I do the animations or add more content to the game, to the engine for part 3? Like, do you wanna see ladders, hovers, and double jumps? Or do you wanna see actual animations, models, stuff that make the game look prettier? let me know in the comments below, or yeah, I guess it's better on YouTube or on Twitter actually. Let me know in the comments below or on Twitter. Then yeah, you can also find me on Discord, or you can get to MegaMan World if you wanna join the MegaMan specific Discord that you can find me at. Then check out my other projects. Feel free to if you want to. On Twitter, Discord. Oh yeah. Also, the most important, check out the project on GitHub, as the full thing uh, with comments is gonna be there. So check that out if you want. Thanks for watching and see you later. Or the usual YouTube stuff. You know the drill.